Dear students, in the previous classes we discussed about the alcohols, that is alcohols preparations and classification preparations and physical and chemical properties of alcohols we are discussed in the previous classes. In this class, we are going to be discussing about the next class of compounds in this chapter, that is phenols. Then in this phenols, there is phenols means phenols we can be defined as aromatic hydroxy compounds. This can be defined as a aromatic hydroxy compounds in which the OH group is going to be attached to the aromatic ring. The simplest member in this class of compounds is phenol. This the phenol having the molecular formula, that is the C6H5OH. C6H5OH. In this the OH group is the function group. OH group is the function group. This OH group is attached to the aromatic ring directly. Aromatic ring directly means the carbon which is having the sp2 hybridized carbon. That is the carbon. The OH group is attached to the carbon which is having the sp2 hybridized, that we call as a phenol. This about the structural formula of the phenol. In this, the OH group is attached to the carbon of sp2 hybridized carbon. Which is the carbon which is sp2 hybridized carbon. In this we call as a phenols. Next, we are going to be discussing about the classification. The classification, when it comes to that classification of phenols. That is when it comes to the classification of phenols, that is the phenols can be classified based on the number of OH group is attached to the aromatic ring. These are classified into, that is, mono, di or tri, that is triphenol or triheaded phenols. Like this we are going to be classified in the phenols. That is, phenols can be classified based on the number of OH group which is attached to the benzene ring, aromatic ring, that we call based on that we are classified the phenol. That is going to be classified into monohydric phenols. The first one we called as a monohydric phenols, dihydric phenols, trihydric phenols. Here we will study one by one. First, we are going to be studying about the monohydric phenols. The name itself indicates that is mono. The name itself indicates that mono means these are the phenols in which the one OH group is directly attached to the aromatic ring. That type of phenols we called as a monohydric phenols. We will take some examples. The first phenol is example for the monohydric. The phenol is example for monohydric. This is about the phenol. This is example for the monohydric phenols. Then if you are going to attach some one more group to this phenol, that also monohydric phenols, that is CH3. Then the name of this compound is 2-methyl phenol. 2-methyl phenol. This is also example for the monohydric. Why it's monohydric phenol? Because only one OH group is attached to the aromatic ring. Only one OH group is attached to the aromatic ring. Therefore, it is called as a is called as a, that is if you are going to take that is NO, that is the OH. If you are going to take that is the 3-nitrophenol. Like this, we are going to be taken some examples for the monohydric phenols. That is the only one OH group is attached to the, that is aromatic ring. That type of phenols we called as a monohydric phenols. The next comes to that there is a dihydric phenols. Di means the name itself is going to be defined. What is di means two. That is these are the phenols in which two OH group is attached to the, directly attached to the aromatic ring. That we called as a dihydric phenols. That we call it as a dihydric phenols. In this dihydric phenols, we'll take some example for this about the monohydric. Examples for the monohydric. Then we'll take for the examples for the dihydric. If you are going to be taken, I said that two OH groups should be attached to the one aromatic ring. That is we call it as a dihydric phenols. In this, the name of this is benzene 1,2 diol. That is 1,2 diol. If you are going to be, that is in the ortho position, one OH group is in that ortho position. If you are going to be taken in the para position, then this also, the name of this compound is benzene 1,4 diol. Means here the position we are going to be taken is 1. The next we are going to take as 2, 3, 4 like that. Means these are the examples for that. That is dihydric phenols. The next we are going to be discussing about the trihydric phenols. Name itself indicates. That is these are the phenols in which 3 OH groups. That is 3 OH groups is attached to the aromatic ring directly. That we call as a, that is trihydric phenols. In that, take some example for this trihydric phenols. That is OH, then OH, then OH. The name of this is that we are going to be taken as benzene 1, 3, 5. That is triol. Like this. If you are going to be taken another example for this, that is OH, then OH. The name of this is benzene 1, 2, 4 triol. Means the number of the OH group is attached to the aromatic ring. Based on this, the phenols are classified into these 3 types. That is mono, di, tri. If the only one OH group is attached to the aromatic ring, that we called as that type of phenols we called as monohydric phenols. If 2 OH group is attached to the aromatic ring, that we called as a dihydric phenols. If 3 OH group is attached to the aromatic ring, that we called as a trihydric phenols. Now we are discussing about the preparations of phenols. That is the preparation of phenol. That is the preparation of phenols. This phenol can be prepared by different method by using the different reactants. That is one of the method is we use that is the preparation of phenol is from haloalkanes. From haloarenes. This haloarene, that is chlorobenzene. The chlorobenzene we are going to take haloarene means halogen containing aromatic compound. that we call as halocarine. This I'll take the example, that is a chlorobenzene. The chlorobenzene I am going to be taken the example. This chlorobenzene is going to be treated with the sodium hydroxide. It's treated with the sodium hydroxide, that is NaOH at the temperature. I am heating with the NaOH at the temperature 623 Kelvin and 300 atmospheric pressure. 300 atmospheric pressure. At that time, sodium phenoxide is going to be formed. That is, at that time, it's going to be formed that sodium phenoxide. That is, sodium phenoxide is going to be formed. Or NA. This we call that as a sodium phenoxide. This on further acidification. We are going to be get that phenol. This is one of the method of preparation of the phenol. In this, what we done from the halocarines, that is the chlorobenzene. I took the example for the halocarine. That is the chlorobenzene is going to be heated with the NaOH at the temperature 623 Kelvin at the 300 atmospheric pressure. At that time, the sodium phenoxide is going to be formed, which on further acidification, we are going to be get that phenol. This is one of the method of preparation of the phenol. In the next method, by using that, the another method from the benzene sulfonic acid. From benzene sulfonic acid. There is from benzene sulfonic acid. In the benzene sulfonic acid, that is the first we are going to be taken the benzene. The benzene we are going to taken. This is going to be treated with the oleum. That is, oleum is nothing but the H2SO7 that we call as oleum. At that time, we are going to be get that benzene sulfonic acid, that is SO3H. This on treating with the NaOH. At that time, we are going to be get that. SO3Na. The name of this compound is sodium benzene sulfonate. That is we call as a sodium benzene sulfonate. Sulfonate is going to be formed. This again is going to be fused with the sodium hydroxide. Again is fused with the sodium hydroxide. At that time, we are going to be get that sodium phenate. That is ONA. This we call as a sodium phenate. Based on acidification, which on further acidification, we are going to get that phenol. Further acidification, we are going to get that phenol. This is the another method of preparation of the phenol. That is, first we are used that halocarine we are used in the preparation of phenol. In the next step, we are used that is benzene sulfonic acid. This we call as a benzene sulfonic acid. By using this also, we can prepare the phenol. That is, the benzene sulfonic acid is going to be fused with the sodium hydroxide. At that time, sodium phenate is going to be formed, which on further acidification, we are going to be get that phenol.